In instructional design, all theoretical planning eventually collides with reality. There is a specific moment where the carefully structured curriculum hits the learner. For decades, learning and development professionals have mapped this process using the ADDIE framework: analyze, design, develop, implement, and evaluate. This chart breaks down the 5 phases of that ADDIE model. To locate where modern digital instruction typically breaks down, we have to look specifically at the 4th step, the orange bar labeled implement. Historically, implementation was synonymous with the physical classroom. An instructor stood in a room, read the physical cues of the audience, and delivered the material. The rapid adoption of virtual instructor-led teaching, or VILT, disrupted that historical norm. Entire curriculums were abruptly forced through video conferencing software. This shift created a persistent professional misconception. Many educators assumed that a Zoom or Teams interface operates as a one-to-one substitute for 4 walls and a whiteboard. Translating a physical lesson plan directly into a live virtual interface breaks the learning experience. The environment behaves entirely differently. Successful implementation requires structurally adapting to the constraints of the new digital medium, rather than porting physical habits onto a screen. The failure to adapt creates an invisible barrier that destroys learner engagement in virtual sessions. To understand this barrier, we evaluate cognitive load, the total amount of mental effort being used in the working memory to process information. A physical classroom naturally minimizes extraneous cognitive load. The physical space provides context, eye contact supplies immediate feedback, and the environment naturally limits distractions. In a virtual environment, software operation competes with curriculum. Both face a dual load. The facilitator manages presentation tools and chats, speaking to blank screens. Simultaneously, the learner burns mental cycles hunting for the microphone and navigating bandwidth drops. The consequence of this dual overload is severe. Neither party has the remaining mental bandwidth necessary to process the actual subject matter. Many designers attempt to solve this engagement problem by layering on more live interactive tools, like third-party polling or instant messaging. Piling on interactions usually exacerbates the friction. The added software requirements cause learners to drop out, either mentally from confusion or technically from poor connectivity. VILT fails because pushing complex instruction through a single, real-time digital bottleneck causes total architectural collapse of the learner's attention. To fix this, we have to decompress the real-time learning environment. We achieve this through the modality split. This strategy divides the curriculum strictly based on its time dependency. The first track in this split is asynchronous learning. Asynchronous delivery is self-paced, entirely learner-driven, and occurs at different times for different people. Its primary advantage is allowing the student deep focus on foundational knowledge, free from real-time pacing pressures. The second track is synchronous learning, representing the live virtual session where the group is paced together at the same time. Synchronous time must be treated as a scarce and highly expensive resource. This live track should be reserved exclusively for complex doubt clarification, active peer collaboration, and targeted instructor feedback. Forcing an asynchronous task, like reading a long text or watching a standard lecture, into synchronous time wastes that resource and guarantees cognitive overload. An instructional designer must assign the delivery modality based strictly on the cognitive demand of the task, completely ignoring the convenience of standard scheduling. Once you separate the time dependency, you have to allocate the digital real estate. Where does all of this self-paced, asynchronous material actually live? This 2x2 matrix charts the 2 primary technologies used to host online learning, mapped across their structural flexibility and design focus. The traditional solution is the Learning Management System, or LMS, located in the closed, highly structured quadrant. An LMS functions as a top-down virtual library. Administrators control the catalog, deploying formal instructional design and aggressively tracking course completion status. While excellent for mandatory training, an LMS is heavily limited when it comes to capturing informal, peer-to-peer knowledge sharing. To address those limitations, the industry evolved toward the upper right quadrant, the Learning Experience Platform, or LXP. An LXP mimics the mechanics of social media. Rather than relying entirely on closed administration, it relies on user curation, content aggregation, and AI to recommend relevant material. This open system facilitates social learning. It allows motivated users to pull the specific content they need dynamically, rather than waiting for an administrator to push it to them. The infrastructure you choose dictates the resulting user experience. You deploy an LMS to prove strict compliance, but you deploy an LXP to foster continuous, self-directed discovery. We can observe how properly managing modalities and infrastructure pays off by looking at a high-stakes live virtual session. Breakout rooms are the most commonly deployed feature for virtual collaboration, and they are consistently the most mismanaged. The typical failure point occurs right as the groups separate. Participants routinely spend their limited live minutes arguing over the instructions for the task, rather than executing it. The structural fix is simple. Strip all administrative explanation completely out of the live session. Email the instruction files and reference URLs to group leaders asynchronously, well before the live session even begins. Let them review the parameters on their own time. Real-time digital bandwidth is the single most valuable resource in online learning. It must be aggressively protected from administrative friction. The ultimate synthesis of these modalities and digital platforms is known as blended learning, sometimes adapted into the flipped classroom. By combining these strategies, we can break down the anatomy of a perfectly architected digital learning day. The day kicks off with a brief 30-minute synchronous session. This time is used strictly by the facilitator to set goals and assign the day's tasks. Next comes the heavy lifting, a 1-hour asynchronous block. Learners log into the LMS to absorb the core concepts independently, pacing themselves through the material. The group then reconvenes for a 1-hour synchronous session. Here, the facilitator answers specific doubts generated during the independent work and guides peer collaboration. This specific pacing sequence eliminates the cognitive overload typically experienced when sitting through a 4-hour Zoom lecture. True online implementation requires engineering a multimodal ecosystem that actively respects human attention.